Hello and welcome to my video on ER modeling. In this video I'm going to go through the process of ER modeling basically. I'm going to touch on the ER diagram, a couple of different types just so you get a little refresher there, and also the relationships between the entities in the tables, or between the tables basically. So this is the ER diagram I've chosen to make. ER diagram stands for Entity Relationship Diagram, and it consists of entities and attributes and the relation between the different entities. The entity is basically tables, or table, entity equals table. So leagues is a table, or is going to become a table. Attribute is the same as column, and difference between, or the main difference between an ER diagram and a complete table is that there are no rows and no extra information in an entity relationship diagram. So what you see here is basically the table name and the columns. The entity I've decided to make is called leagues. It draws inspiration from sports leagues or esports leagues, as you'll probably see if you look down here. So just to give a quick explanation of what I've been thinking going through or while making this entity relationship diagram. First I chose a league ID. This is put a primary key in my my first entity here, which I'll later use to hook my teams table to. So these are in relation to each other, and we'll get to how this is not in relation to this, so players are not in relation to leagues. So for the attributes I've chosen, first the name of the league. Usually you want to know the name of the league. This is basically how you think when you start making a model or a diagram of how a database is going to become in the future. You'd also probably like to know where the league is hosted, or in which country, which area, which state, whatever. Also, I've chosen to display the number of teams. So if there are 13, 14, 15 teams in the league, and I've chosen to set a foreign key here. This is the team name, and that's what connects these two tables. So this foreign key, as it says, is the column on which the connection to another table is located, or the attribute, if you want to swap out the word here. That's the primary key, as you can find in as a foreign key in Teams. It's a unique indicator which other tables can connect to. So that's basically the references. If you need to read up on primary key and foreign key, or you want to look at the different explanations I put in the Word document over here, then you can just pause the video and have a look. So in the Teams entity, I've chosen to put team ID. So the team has an ID, or an international ID if you want to go through different leagues. Also the team name, of course. It's important when making a team is to have a name. The league ID, which league they play in, or the ID of the league they play in. And I've also put another foreign key here, which connects back to the name of the league, because you'd like to know which league the team plays in. If it's a Taiwanese league, or American league, or Brazilian league, whatever. And I've chosen our 4 cardinality in this relationship between these two entities. I've chosen a one too many, and the reason behind this is that a league can have many teams, but a team can only belong to one league. You can't play in different leagues at the same time, basically. So there's a one too many. Also, leagues can exist without teams. If you have, for example, or in gaming this is more prevalent, I guess. You have like internationals and stuff, so only the teams are not picked out of standings or whatever. Games have to be played first, and then the teams add up into the international over time as they get enough circuit points, or yeah, that's basically how it works. So that's the reason why it's a one too many. So again, a league can have many teams, but a team can only belong to one league. A bit of the same logic actually applies to the relation between teams and players. A team can have many players, but a player can only belong to one team because of generic practice. In football this is different because of national leagues and whatever, but in League of Legends there's no, or in Asia there has become a league for this, but not in Europe and NA and whatever. So again, a team can have many players, but a player can only belong to one team. Also, the leagues table, leagues entity, the team's entity and players entity are all strong entities, as shown by the stapled line here, which means a non-identifying relationship. So they can all exist on their own. We could make a table with just player names. For example, if they don't have a team, you can just have players, basically. How it works. This is also the case with ranking systems in Hearthstone and stuff. There's players on the ladder, but they don't have to belong to a team. And yeah, and the same thing goes here. The staple line just to showcase that these entities are all strong entities. So just to touch on the types here. Int stands for integer and means numbers, so you can put numbers in here. That's like a restriction, you can only put numbers in here, and also excludes the possibility for null, which can't be used for primary keys. Varchar I think stands for varying character, so that means you can vary the length of your name or sentence, whatever, between 0 and 50 letters, and this is used 3 times, as you can see, and that's another int. I want to touch on char or character. This command is pretty similar to varchar, but it makes it so if you type 10 in the parentheses here, you have to write 10, or it won't work, basically. Decimal is also another type, and this type makes it so you can type in decimals between or at the back of, say if you have a KDA, for example, as I'll put in later, you can have a decimal type for it, so you can put 8.3 for example as a KDA. Now I'm going to create another one of those entities. So this one I'll actually call standings, because usually when you have a league and you root for teams, you want to see the standings and how well they're doing. So let's just plot in some data here. Let's say team standings. This basically means first, second, third, 15th, whatever. Also, the team KDA is usually something you want to find in games, as I touched on earlier. Then we'll put a foreign key here, and it will stand to team name, so it'll be a foreign key connecting standings to teams. And then we'll create another row with an other foreign key, which we'll use to connect the name of the league, which connects standings to the league's entity. So we're reaching 10 minutes here, so I gotta be quite quick, I guess. Between these tables, or the special thing about standings is that it's a weak entity to start from the easy part here. So this means the line has to be a whole line, which indicates that it's an identifying relationship. Standings cannot exist on its own, as you can read here. So, and now we're going to go through some of the logic between why I choose the different things here. So this one and this one. Yeah, so this is many to many relation. There can be a lot of leagues and a lot of standings. So there has to be a many to many. That's my reasoning behind choosing this. Also, there will always be one league, but there doesn't have to be standings. And a bit of the same logic applies here. It's a weak entity. And see here, the only difference here is that this is a 1-2-1. But this is still a 0. The standings doesn't have to exist for teams to exist. So, or the standings doesn't have to exist. Teams will have to exist. So that's my reasoning behind choosing what I did here. So, quick summary of this: been through the ER diagram, identity relationship, touched on entity, table, attributes, column, short explanation of primary and foreign keys, different types you can use in your tables, and the relationships between the different entities in my ER diagram. Thank you for watching.